last problem. So let's start by looking at the equations in this problem. Both of these equations are in terms of x, which means we're going to be doing top minus bottom on this one. Because it's in terms of x, it's top minus bottom. So, example 3, set up integrals for the total area of the regions located between the two curves as shown. Now, this problem actually has something that we need to be very, very careful about. And it's because, let's start by looking at this area here. If I look right here, I can see that this red curve is on top, and this yellow curve is on bottom. However, if I look over here at the blue part, now the yellow curve is on top and the red curve is on bottom. So if I want to do top minus bottom, I actually need to do two integrals here and add them together. Where this first integral is the green one, which is going to be the red one minus the yellow one, top minus bottom. And this one here is the blue one, which is going to be yellow minus red, because now the yellow is on top and the red's on bottom. So let's look at this green one first. Let's see. We have our limits, which will be the x values of our intersection points. So there's our intersection points. These are x equals limits because we're in terms of x. Now, if I look at this x value, that looks pretty darn close to -2. But like we learned in the last video, if you assume that's a -2, you would actually be wrong this time. So to confirm what the intersection points are, we're going to set the equations equal, that should be negative, to each other, and then solve. In this case, you cannot solve this one algebraically. This is a calculator problem, where you put that into y1, put that into y2, and then find out where they intersect. And you'll find that those intersection points are this. Those are the three intersection points. So this one right there is this first one. Right there. And then that one is indeed 0. So my limits are going to be from -2.024 to 0. Okay, my limits are in terms of x. Now let's do the red one minus the yellow one. This one is the red one. How do I know? Because the red one is cubic, a cubic shape, and that's a cubic equation. This one's got to be the yellow one because it's a parabola, and that's my yellow parabola shape. So this first one's going to be red minus yellow, x cubed minus x squared, minus the yellow one, -x squared plus 4.1x. And then this one, I have my new limits. Let's do these ones in blue, keep with our color theme. And it's going to be this one, which is going to be my 0. And that one right there, which is going to be my next intersection point. So from 0 to 2.024. Now this one is the yellow, so -x squared plus 4.1x. Top minus, I'll put that over here, top minus bottom. Top minus bottom. And in this case, the red one is now on bottom. Oh, and I forgot my dx's. Be careful about that. So this is actually your integral. And thank goodness this one says we only need to set up the integral. We do not need to solve it. However, with the calculator, solving this integral isn't too bad. The only thing you have to be extra careful with is these points right here. Those are decimals. And if you round them to this in the actual problem, you will get it wrong. So when you find this intersection point on your calculator, you're going to want to hit second, quit to go back to the main screen, and then you're going to hit your store button. And that store button will automatically take this first point that you just found the intersection for, and you want to store it as a letter. Then when you find this intersection point, you'd want to hit second, quit, and store it as a different letter. Let's say Q. And then when you're actually plugging in these integrals, you don't want to type in the approximated decimal. You want to use the actual number, the whole stored number, not just part of it. So then in this integral, you would type in the letter that you stored those numbers in. If that doesn't quite make sense, please let me know. I'll try to explain it to you in person a little better. That is all for this problem now. You should be able to get started on your homework.